Hello, friends. Welcome to Science Talk. I am your host, Jim Massa. Well, here's another Greenland ice melt report to share with you. Greenland's ice melt itself enhances glacial instability. In other words, it adds to it. Think of it as another runaway positive feedback loop effect. So as the ice melts, surface water, finds its way down to the bedrock, it's doing so at increasing speeds, unexpected speed. But now what happens when that water gets to the bedrock? It acts as a lubricant and allows the ice itself to move along. The glacier sheet itself will move along at an increased rate. So British scientists have observed a huge ice sheet in the process of draining away, with, of course, significant effects on the surroundings. They've seen what happens to the water created when Greenland ice melts. For the first time, with help from drones, researchers have witnessed water flowing at 1,000,000 cubic meters an hour from the surface of ice sheets through caverns in the ice and down to the glacial bedrock. Now, in oceanography, we actually have a special term for this. Now, they're saying 1,000,000 cubic meters per hour, but in oceanography, we actually call a 1,000,000 cubic meters a sphere drop. And we actually measure it as in per second. So when you're looking at massive volumes, of oceanic water masses, just moving, you get these huge things here. A sphere drop is 10 to the 6 cubic meters per second. That's a sphere drop. This is per hour, so it's a little slower, but still, 10 to the 6 million cubic meters. That's a lot of water. Now, of course, this just simply is another study reconfirming what's happening with the rapid ice melt in Greenland as the temperatures increase, CO2 levels increase. But it does give us some insight into the mechanisms by which the glaciers melt and then go into, melt into the sea. What it does tell us is that many of the estimates, or it suggests this at least, of the melt rate are, here we go again, underestimates. Greenland is the second largest ice sheet, right, after Antarctica, of course, and is a major contributor to global sea level rise. Right, so we've known about that concern. Okay. So researchers from the University of Cambridge, Aberystwyth, and Lancaster have now been able to put a measure on surface water loss. So a report published in Proceedings of the National Academy of Sciences. They use custom-built drones, complex computer modeling, to work out the mechanism by how the fractures form below the vast lakes of meltwater that form on the surface, and then what happens to there. And they actually named one of these glaciers Store Glacier on the island's northwestern sheet. Apparently it stores water. They watched splits form in the glacial ice to suddenly open up an escape route for this pool of water on the surface. And such fractures became caverns, which are called moulins. And in one case, 5 million cubic meters of water flowed in just 5 hours. 5 million cubic meters of water. So, they were talking about 10 to the 6 cubic meters per hour. It's 5 times that amount. The ice of the glacier is typically a kilometer thick, so scientists may have observed basically a very long waterfall, perhaps the longest on the planet. And as I mentioned before, as the ice drains away to the bottom of the ice sheet, that liquid water may serve as a lubricant to speed up the flow of the glacier over the bedrock. The ice sheet was lifted by 1/2 meter in response to the subsurface flood. 4 kilometers downstream, glacial speed picked up from a speed of 2 meters to more than 5 meters a day. You've got a kilometer thick of ice and you raise that entire thing 1/2 meter? Holy shit, that's a lot of force. Seriously, that's... Water is a very powerful force. So Tom Chudley, who's of the Scott Polar Research Institute in Cambridge, one of the authors and lead scientists, it's possible we've underestimated the effects of these glaciers on the overall instability of the Greenland ice sheet. It's a rare thing to observe these fast-draining lakes. We were lucky to be in the right place at the right time. Until now, scientists have been able to estimate glacial flow and surface melt only by satellite studies, which does not give us a lot of detail, or perhaps direct on-the-ground measurement under conditions that, even in good weather, are very challenging and difficult. But thanks to this drone technology, they've been able to calculate a little more accurately the shrinkage of the Greenland ice sheet at the rate of 1 billion tons a day as temperatures keep going up. What they want to do next is deploy drilling equipment so they can get a better look at how the water gets below the glacier to reach the bedrock. So they want to figure out that mechanism and then calculate how the ice sheet may change, not just over hours, but over the coming decades. Paul Christopherson, who was the main principal investigator, states these glaciers are already moving quite fast, so the effect of the lakes may not appear as dramatic as on slower moving glaciers elsewhere, but the overall effect is in fact very significant. So they're starting to quantify better, the rate that the ice loss melts, as well as overall ice loss in effect. And flickering lights here. And what all this tells us is that Greenland is melting a lot faster than previously expected. And this will definitely impact sea level rise, along with thermal expansion, and what happens to AMOC, which is my next story. Stay tuned. Thank you for your time. Hello folks, this is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.